MRIs exploit similar physics that astronomers use to study gas all across the universe. Yesterday I got an MRI and I would show you my actual images, but they gave them to me on a CD-ROM. What am I supposed to do with this? I haven't had the technology to read what's on this in many years. Why would they give me a CD-ROM? Anyways, first let's understand what an MRI does. So the human body is mostly water. About 3/4 of your body is just water. This is true for most living organisms. This is also one of the many reasons why we suspect that life requires water elsewhere in the galaxy. Each water molecule in your body has two hydrogen atoms, which are a proton and an electron. Now, without getting too deep into it, each of those protons have this property called spin. They aren't spinning, but they do have a measurable quantum property called spin, but they are not spinning. Now, this spin property basically makes the protons like tiny little bar magnets. Normally, those little bar magnets in your body would just be pointing in every random direction, but when you go inside of an MRI, you are entering a strong magnetic field, which aligns all of your protons up. Then the MRI, which is very loud, sends finely tuned radio bursts that are at the exact right frequency to knock those little magnets out of alignment. And then when the pulse stops, those magnets relax back into place to be in alignment with the magnetic field. And when they do that, they emit their own little radio frequency, which is picked up by the machine. Then by using magnetic gradients, they can tag where the signal came from and reconstruct a 3D, like topographic model of what the inside of your body looks like based on the signals coming from those protons in the water that is making you up. This is where the astrophysicist inside of me gets excited, because the physics of the protons inside of your body is the same as the physics that the protons on the other side of the universe experience. Out in space, there will be hydrogen gas all over the place. And every once in a while, the electron will flip spin signs relative to the proton. When this happens, it emits a radio wave that is 1420 megahertz or 21 centimeters in wavelength. This is called the hyperfine transition. We are using the magnetic properties of hydrogen, but in this case, instead of mapping out the inside of your body, you're mapping out the distribution of hydrogen gas in the galaxy. This entire process is called nuclear magnetic resonance, which is why MRIs used to be called NMRIs, nuclear magnetic resonance imaging, because you are imaging the magnetic resonance of the atomic nucleus of hydrogen. Anyways, this is yet another example of fundamental physics research, not only helping us understand the universe, but literally turning into life-saving technology.